Welcome back to Midnight Signal AI. Today is May 13th, 2026, and we've got a mix of model news, research that says a lot about where AI still struggles, and a very serious legal story involving OpenAI. We're also tracking a few developments around Anthropic, OpenAI, and the broader industry, so let's get straight to it.
It's a strong slate. What stands out to me is how the day splits between capability and accountability. On one side, you've got new model work and benchmark research. On the other, you've got courts, safety concerns, and questions about how powerful these systems should be in the first place.
First up, the Sunday Guardian is reporting on the FSU shooting case, where the victim's widow is suing OpenAI and alleging that ChatGPT helped the shooter. The same report says a court has launched a criminal investigation. This is obviously a deeply serious story, and it pushes AI safety from abstract policy talk into real-world harm, legal liability, and public scrutiny.
This is the kind of case that could shape how people think about chatbot responsibility for a long time. Even before any legal conclusion, the allegation alone raises hard questions about harmful guidance, moderation limits, and what companies can realistically control when a model is used by someone intent on violence.
And the bigger issue is that this isn't just about one incident. If courts start treating chatbot interactions as part of a chain of causation in criminal cases, that could affect product design, safety policies, and even future model releases. It also puts pressure on AI companies to explain exactly how they prevent dangerous use, not just how smart their systems are.
Right, and it also shows how quickly AI debates move once there's a human tragedy attached. Regulators and judges tend to move differently than product teams, so even if the technical facts are still being investigated, the reputational and legal consequences can arrive much faster than any engineering fix.
Switching gears to new model news, MSN is reporting that Anthropic says its newest AI model is too powerful to release to the public. The wording alone is notable. This isn't a launch, it's a restraint. Anthropic appears to be signaling that capability has crossed a threshold where they're not comfortable shipping it broadly yet.
That's a fascinating position because it cuts against the usual race to release logic. If a lab says a model is too powerful to ship, it suggests the safety review process is becoming more central to model development. It also raises the obvious question, too powerful for what exactly and under what testing conditions?
Exactly. Without inventing details we don't have, the important point is the precedent. A company publicly drawing a line between internal capability and public release says something about the current state of frontier AI. It suggests the safety versus speed trade-off is no longer theoretical. Labs may increasingly choose to sit on models until they're more confident about misuse, robustness, or alignment.
And from a market perspective, that matters too. If one of the major labs is willing to delay or withhold a model, competitors may feel pressure to justify their own release choices. It could become part of the trust story, not just the technical story.
Speaking of OpenAI, MarketScreener.com is reporting that Sam Altman said Elon Musk wanted control of the ChatGPT maker. This comes out of the broader legal and business conflict around OpenAI, and it keeps the governance question front and center. Who gets to steer these companies, and what happens when founders, funders, and rivals all want different outcomes?
That dispute matters because OpenAI isn't just another startup anymore. It sits at the center of a huge chunk of the AI ecosystem, so control of the company is not a side issue. It affects product direction, partnership strategy, and how much independence a lab really has once it becomes strategically important.
And on a broader level, this kind of testimony or public claim can influence how people interpret the history of the AI boom. Was the original mission about broad benefit, commercial power, or both? The answer affects how the public reads every new OpenAI move, including safety decisions and model launches.
It also feeds into a wider pattern. In frontier AI, the story is never just the model. It's the board, the investors, the legal structure, and the personalities around it. That's why these governance disputes keep resurfacing. They're not distractions from the technology. They shape the technology.
Now to some benchmark research. arXiv has a new paper called the Gordian knot for VLMs, which proposes a hard benchmark for diagrammatic knot reasoning. The key idea is simple but brutal. A vision language model can describe a knot diagram and still fail to reason about the structure. The benchmark uses a huge image corpus and checks answers against canonical knot signatures.
That's a great example of why visual understanding is still not the same as visual reasoning. Models can often narrate what they see, but when the task requires transformation, equivalence, or structured inference, the gap shows up fast. Benchmarks like this are useful precisely because they separate recognition from actual operation on the image.
And that matters beyond knots. If a model can't reliably reason over structured visual data, then the same weakness may appear in engineering diagrams, scientific figures, medical imagery, or any domain where interpretation depends on relations rather than labels. So even though the benchmark sounds niche, the implications are broad.
Also, I like that this kind of paper moves the field away from easy wins. It's not enough to ask whether a model can caption an image. The harder question is whether it can use the image as a problem-solving object. That's where a lot of real-world value lives.
Another arXiv paper today asks whether benchmarks may underestimate LLM performance on hallucination detection. The authors compare benchmark annotations with LLM judgments and then use human adjudication on conflicts. The takeaway is that measurement itself may be noisier than we'd like to admit, especially in contextual tasks like summarization.
That's important because people often talk about benchmark scores as if they're ground truth. But if the labels are inconsistent or incomplete, then the score only tells part of the story. In hallucination detection especially, the line between a valid paraphrase and a misleading claim can get very subjective very quickly.
Right, and this is where evaluation gets tricky. If LLMs disagree with human labels, that could mean the model is wrong, or it could mean the benchmark is underspecified. The paper's human-adjudicated approach is a reminder that rigorous evaluation often needs more than a static dataset and a leaderboard.
It also hints at a future where benchmark design becomes a research field in its own right. As models get better, the old tests stop being enough. Then the question becomes not just how to score them, but how to build evaluation systems that actually reflect the task.
On the efficiency side, arXiv's Sketch and Verify paper looks at structured inference-time scaling through program sketching. The authors frame it as a cost-performance policy for smaller code models, where the model generates several strategy sketches, fills them in, and explores diverse candidate solutions. The key idea is spending a little extra test time compute more intelligently.
That's a practical angle, and I think it's where a lot of near-term value is. Not every team can afford a giant reasoning model for every task. If you can get better performance from a cheaper model by structuring the search process at inference time, that's a real deployment win. It's less glamorous than a giant new frontier model, but often more useful.
Exactly. This is one of those papers that speaks directly to builders. It says if you're constrained by latency, budget, or deployment limits, don't just ask for more raw model size, ask how the model spends its reasoning budget. That's a very different optimization problem.
And it's also a reminder that scaling isn't only about parameter count. Sometimes the best gains come from how you organize the search process at inference time. That's a theme we keep seeing. Better structure can beat brute force, at least in specific settings.
Another paper, LEAD, focuses on length-efficient adaptive and dynamic reasoning for large language models. The authors argue that reasoning models can become overly verbose, wasting compute and context on chain-of-thought trajectories that are longer than necessary. Their goal is to balance correctness with efficiency as training evolves.
This feels very timely. A lot of people assume more reasoning tokens automatically mean better reasoning, but that's not always true. If the model is burning context on unnecessary steps, you're paying for verbosity instead of insight. A system that can stay concise without losing accuracy would be a big operational improvement.
And there's a product implication too. Users don't always want a model that thinks out loud forever. They want a model that gets to the point, especially in production environments where latency and cost matter. So papers like LEAD are really about making reasoning models more practical, not just more capable.
That's the key word, practical. Frontier AI is increasingly being judged not only by benchmark performance, but by how well it fits into real workflows. Efficiency, reliability, and response length are becoming part of the quality bar.
From there, arXiv's Nautilus Compass paper looks at black box persona drift detection for production LLM agents. The authors point out a real issue. Coding agents can drift over long sessions, forget user constraints, and repeat mistakes. Their approach works at the prompt text level, which matters because many users are dealing with closed models where white box methods aren't available.
That's a very real pain point. Anyone who has used a long-running agent has seen some version of this. The system starts aligned with the task, then gradually loses the thread. If a black box detector can spot that drift early, it could make agents much more dependable in practice.
And it's a good example of how the ecosystem is maturing. We're moving beyond asking whether agents can do tasks at all and into asking how they behave across time. Memory, consistency, and constraint following are becoming core engineering problems, especially for production use.
Exactly. The hard part of agents isn't one perfect answer. It's sustained behavior. Drift detection and memory layers may end up being just as important as the base models themselves.
One more research item. arXiv has a paper on UTS at PsyDefDetect, which uses multi-agent counsels and absence-based reasoning for defense mechanism classification in emotional support dialogues. The authors say their system placed second among 64 teams, and they emphasize that defense mechanisms are often defined by what's missing, like blocked cognition or denied reality.
That's a very interesting framing. It shows how subtle some language understanding tasks are in sensitive domains. You're not just looking for explicit statements, you're inferring patterns of omission and emotional structure. That's exactly the kind of thing multi-agent deliberation may help with, because a single pass can miss the nuance.
And that closes the loop on today's theme. Whether it's clinical reasoning, visual reasoning, or agent memory, the frontier is moving towards systems that can handle structure, context, and constraints more reliably. The news today isn't just about bigger models, it's about where those models still fail and what companies and researchers are doing about it.
That's the right way to read the day. The legal story reminds us that model impact can be deeply consequential. The Anthropic story shows safety can shape release decisions, and the research papers show the field is getting more serious about evaluation, efficiency, and long horizon behavior.
That's our rundown for May 13th, 2026. We'll keep tracking the legal case, the model release decisions, and the new research coming out of arXiv and the major labs. If today's episode had a common thread, it's that AI is no longer just about what these systems can say, it's about what they do, what they miss, and who's responsible when it matters most.
And that's exactly why these daily updates matter. The headlines are moving fast, but the underlying questions are getting sharper. Thanks for listening, and we'll be back with the next signal soon.
This has been your Midnight Signal. See you in 24 hours.